Good afternoon, everyone. Thank you so much for coming. I hope you're all having a really great couple days at RailsConf so far. I just wanted to introduce myself. I'm Jordan Raine. I'm from Vancouver, Canada. And if you want to reach me, I'm at JN Raine on most places. I'm a staff developer at a company called Clio. And like I said, we're based in Vancouver. And since 2008, we've been using Rails to try to change and improve how lawyers and law firms practice law. And if you're interested in this, come talk to me afterwards. And we are remote friendly. So today's talk is about how getting lost in somebody else's code is sometimes the best thing that you can do. And it starts with something that I think a lot of us have experienced pretty often. Now, I love to program, and if you give me a problem, I can go for hours and hours, but sometimes it can feel like half of our time is spent here trying to figure out what to do next. And I've been writing Ruby code since the Rails 2.3 days, but before that, I spent my time writing websites in PHP. And that was a time when this is how you built a website. At the top of the file, you opened a connection to your database, and you crafted a SQL string. Sometimes that SQL string included user input as well. And then once you had the result, you used that to render the page below. There were no models here, and there were very few classes. For the most part, this was the whole thing. And as odd as it seems to look back at this now, adding little snippets of code into HTML files to do everything myself seemed like a very reasonable thing to do. It was all up on the screen in front of me, so when I became stuck, it was often easy to find my way out of it. But obviously, we know now working like this can be limiting. The possibilities for what I can do are reduced to my ability to cram things into a single file and to make sure that I always do things correctly. And when it came time to build something more complex, a coworker pointed me at a framework called Rails. And it really changed what I thought was possible. I didn't have to craft SQL anymore by hand. I could use Active Record. And I didn't have to copy and paste my URLs everywhere I needed to use them. I could use URL helpers. And I could put my code into these nice buckets of behavior using model, view, controller. And pretty much everything became easier. And with generators, Rails would even write the code for me. But because everything wasn't in front of me anymore, when I got stuck, it was deeper than ever before. And when a stack trace was raised, it often only included 1 or 2 lines of my code. And I didn't know the difference between an application trace or a framework trace. And even if I did, I wouldn't know where to look to figure out more. My best defense was to Google the error. And if I found a fix, that was great. And if I didn't, I was left to tweak the code until I made the error go away. Now, every day as developers, you're faced with problems. And one of the beautiful parts of using Rails is that it often has a solution for you. But the longer you work in an application, and the more features you add, the more likely it is that you'll come across something unusual. No one on your team has seen it before, and you can't find any mention of it in the Rails docs or the guides. And it puts you back here. During this session, I want to show you how to get out of this. When you hit a wall and the only way out is to go deep within the Rails code base, you'll know how to find the answer. My hope is that when you sit down at your desk next week, you'll have new techniques that can help you more deeply understand how your app behaves, and you'll be able to teach yourself how any part of Rails works. This talk will be in 4 parts, starting with how you spend your time. A few years ago, a group of researchers wanted to measure how developers spend their time. Specifically, they were interested in how much time we spend on program comprehension. In other words, how much time do we spend trying to figure out what to do? The way they did this was to install software onto the computers of 78 developers, tracking everything that they did. These developers worked at 2 companies, working on real projects. And over a 2-week period, they were able to gather over 3,000 hours of data. And once they had that data, they categorized it into 4 groups. The first was comprehension, which they defined as reading code, reading bug reports, and trying to understand project requirements. This also included any time spent trying things out in a browser or running your tests. The next was navigation, which they defined as browsing through software. Specifically, this was searching Google for answers, searching your code base for that right method to call, or reading about how something worked on Stack Overflow or similar websites. The third was editing, which they defined as adding, modifying, and deleting code, what most of us tend to think of as programming. And then finally, other, which included reading news online, or shopping, or sitting on Twitter. For what we're doing today, it makes a lot of sense to group navigation and comprehension into one bucket, so we're going to do that. And before I show you what they found, think back to your last week. How much time did you spend stuck, or reading on Stack Overflow, or searching Google? And how much time did you spend writing code? So here's what they found. On average, a developer spent 82% of their time on program comprehension and navigation, and only 5% of their time on editing. Only 5% writing code. Now, there's no question that we need to understand what our code does. That time in comprehension and navigation is not wasted. But when I look at this, I can't help but think the less time I have to spend here, the more time I can spend here writing code and providing value. The study also found a laundry list of things that increase comprehension time. And when I read through these and thought about it, it really boils down to 2 things that we can do to make it better. The first one is we can write code that is easier to use and change, and we can improve our ability to find answers. Now, the first one helps future you. The more time you spend today adding tests or writing documentation or being careful about how you name things, the less time you'll need to spend later figuring out how it works. And the second one helps you today understand any code that you're faced with. So we're going to focus on that. The study wasn't all bad news, though. It also found this, that the more experience somebody had, the less time they spent on program comprehension. And when they looked at the differences between the people with more experience and less experience, they found that the people with more experience approached problems with techniques that that allowed them to more easily and more quickly come to an understanding. It wasn't that the more experienced people knew the answer, they just knew how to find it. So, if we want to learn to improve how we understand code, we need to understand what we're up against. And that brings us back to Rails. What makes Rails difficult to understand, and what can we do to prepare for it? First one is that it's big. How big? Well, a new Rails 6 app comes with 77 gems. 12 of those gems come from the Rails repo and include 75,000 lines of Ruby code. And if you include those other 77 gems, it brings with it more than 250,000 lines of Ruby code. Now, for many Rails apps, that means that the Rails framework and all its dependencies is larger than the app itself. The next one is that Rails is complex. If you consider how it's structured, it's in these nice buckets of behavior. They're all small components all built together. And you can look at this, you can see this when you look at the ancestry tree for important classes, like Action Controller Base, which has 65 ancestors, and Active Record Base, which has 67. Now, this is not a bad thing because it allows people to more easily add and extend functionality, but it also means that a single path through the code can touch many different files and sometimes span multiple gems. I'll give you an example of this. When you call save on an active record object, here's what happens. Ruby goes out and it finds the save method, and then it calls it. And then that method calls super. And so Ruby goes back to the ancestor list and finds the next module that implements save, and it calls that. And then that method calls super, and then that method calls super. And so in the end, the behavior for save is split across 4 different files. The order of which is dependent, the order of these calls is dependent on the order that the modules were included. And so if you just went and read the code, it would be difficult to understand exactly what would happen. Next, Rails is dynamic, or you might call it magic. It does everything it can to make our lives easier, but that sometimes requires code like this, which defines a method whose name changes depending on the value of the callback variable, or code like this, which iterates over a list, creates a string, and then evaluates that string as Ruby code. Now, you're probably not going to see this code in many code bases, and so when you come up against it when you come to Rails, it can be difficult to understand. And finally, Rails isn't your code base. Think back to when you started your current job. How long did it take you working day in and out with the same code to get comfortable with it? To understand what all the names meant, or to get used to the coding style? And now consider how much time you spent working in the Rails internal code base. If you're anything like me, you're not opening pull requests to Rails on a regular basis. It's not part of your job. And that means because we're not living in that code base on a regular basis, it means that we don't gain an understanding of that code base for free just because we're building Rails apps at work. So we need some way to navigate around that size and complexity. And that's where code spelunking comes in. To me, code spelunking is the ability to confidently explore an unfamiliar code base and squeeze into the tight corners and follow the twists and turns to find whatever answer you're looking for. Maybe that's in Rails, maybe that's in a different gem, and maybe it's the code base at your job. When I go spelunking, I like to follow these 3 guidelines. Ask a question, start with what you know, and only read code relevant to your answer. So let's give this a try with a pretty simple question. What's the difference between try and try bang? Let's just a quick review of what these do. If you call length on a string, it returns the number of characters in that string. If you call length on nil, it will raise an exception. If you're not sure if something is nil or not, you can get around it by using try. If you call try length on a string, you'll get back a number. And if you call try length on nil, you'll get back nil. It won't raise an exception. What about try bang? Well, it looks pretty similar. Try bang includes returns a number, and try bang on nil returns nil. So they look really similar. In fact, they look identical from this perspective. So why do they both exist? Now, if your first instinct is to go look this up in the Rails docs, that's good. If there are Rails documentation, if there's Rails documentation that can answer your question, you should use it. But let's pretend for a moment that this is our view, and the airplane Wi-Fi is not working. So you have no Rails docs. And this is a great time to use method introspection. if you're not familiar with method introspection, it is a really, really useful feature of Ruby where you can ask objects what methods they respond to and do a few other really interesting things. So let's go back to our, let's pause our existing example and go look at some different code to see how this works. So this is my dog, Foxley, and as you can see, he is a good boy. And we have a class here that we'll use for this example. So if we go to the console and we ask, we instantiate a new dog instance, and we can ask it for all the methods that it has. Now, when you call this, you get this overwhelming list of method names. In fact, they don't fit on this slide. And this is the case for almost every object in your system. Rails and Ruby include a lot of things by default. And so it can be a little bit overwhelming. But there's a really simple way to help this. We can take all of the methods from object.new and subtract them from the dog class. And then we just get back the two methods we implemented. And because the method object, or method returns just a normal array, we can do other things with it, like search through all the methods for anything that includes the word instance. But we can go further than that. We can actually ask it for a specific method. Let's assign it to a variable, and then let's get the name method. And once we have the name method, we can ask it where it was defined. And this will return the path and line number of that method. And we could go to disk and read this, or we could just ask Ruby to do it for us. Now, everything I've shown you so far is just standard Ruby, but this is a little bit different. This comes from a gem called method source. And if you use Rails, you don't need to worry about it. It's already included. But if you'd like to use this somewhere else, just add this gem. So once we call this method, we're going to get back a string of the source code. But because we're at the console, it looks not great. We can get around this by using the .display method, which will print a string to standard out. And then we get back exactly what we had on disk. This works for our code, but it also works for code in gems. If you've ever wondered how something works in Rails, you can just take a peek. And oftentimes when you do this, you learn new things. In fact, I didn't realize that create took an array of attributes until I was preparing this talk. And remember active records save method? Well, we can explore that as well. If we, so we have 4 implementations. And if we get the save method, it gives us back one from active record suppressor. That's where it was defined. And we can ask for the super method. And it'll give us back one from active record transactions. And we can keep going, get one from validations, and one more from persistence. And this will return the exact order of calls as they're going to happen at runtime. Now, there's no other save methods. So if we call it one more time, we're going to get back nil. And there's one gotcha to keep in mind. As you're looking through code and trying to figure out what's going on under the hood, sometimes you'll see this. Source not found. And that's because part of Ruby is written in C. And the methods and functions that are written in C are not going to be available to you, the source code. Now, there is a way to get at them. And I'll touch on that at the end. But for most of the cases, this is not a problem because most of Rails is not C. OK, so back to our existing example. So what's the difference between try and try bang? Well, let's get the source for try, zoom in on it. But before we read ahead, remember the third rule. Only read relevant code. Let's start at the first line and try to get rid of any code that we don't care about. So method name nil and block given. Well, when we called it, we gave a method name, and we didn't give a block. So this is false, which means this code we don't care about. So get rid of it. What we're left with is something pretty simple. If respond to method, public send method. Okay, easy enough. What about try on nil? Take a closer look. Not all of Rails is complicated. Anything we give it, it'll return nil. Okay, what about try bang? Let's do the same thing, get the source code, take a closer look, only read what's relevant. This is still false, and we don't care about this code. What we're left with is something pretty similar. We can pull the two up side by side, and now we can see one important difference between the two. Try bang always calls the method. So if we go back to the console and we send a method name that string doesn't know about, try will return nil, and try bang will raise an error. OK, so I think we have our answer now. Oh, sorry, actually, one more thing. Let's go figure out try bang on nil. And hey, looks pretty similar. They're both exactly the same. So I think we now have our answer. What's the difference between try and try bang? Well, for nil, they're the same. For everything else, try bang is more strict. So actually, let's just review for quickly what we did there. We asked a question. We looked at a couple methods we knew about. In fact, they were right in the question name, word there. And then we skimmed about 20 lines of code and read another 6 to get our answer. But that is for a really simple question that we could have probably answered from the Rails docs. So can we use this for something that's more interesting? Imagine yourself back at work next week. Your manager comes over and says, we need a way to keep track of which request enqueued a job. You see, lately, we've been having a lot of failed jobs in the background, but we are unable to figure out where they came from, what user triggered it, and what request was being made at the time. So we'd really like to be able to print out the request ID when the job fails. Can you figure out a way to add that? Your active job knowledge so far has been that you call perform later, magic happens, and then your job is running in the background. But it couldn't hurt to look at the code. So let's do that. Here's what we're starting with in this code base. We have application controller with a before filter, a before action rather, and it takes the request ID and assigns it to current.requestID. Later on in the controller action, we enqueue a job. When that job runs, we want to have that request ID available to us. Some of the groundwork has already been laid. In application job, we have this request ID attribute. And in that report job that we're enqueuing, we print it out to the console just to test our behavior. So if we do this now, set the request ID, enqueue the job, and then over on our Sidekick console, it's nil. OK, so how do we add the request ID to every job? Well, let's start with what we know and pull up the perform later source code. It's pretty simple. It calls Java instantiate, and then it calls unqueue on the return value. So we want to dive into the enqueue method next to go one level down, but we need the return value of that. To do that, we can call Java instantiate on our job, and then grab the enqueue method from there. When we do this, though, we get an error. It turns out that Java instantiate is a private method, and you probably shouldn't ever call it in production code. But when you're spelunking, you're allowed to bend the rules a little bit. So let's get around that by sending it, and then getting the enqueue method from there. Now, what we get back is a bit overwhelming. It's more code than we've seen so far, and I imagine most people can't read that. And even when I'm at my computer, this can be overwhelming. And so I like to kind of squint a little bit and try to find the natural breaks in the code. And for this, I see 3. Let's take them one at a time. So the first chunk sets a bunch of variables. Depending on the options that are given, we assign those back to attributes on the job. OK, well, we didn't provide any options, so we can just ignore that and look at the next one. Now, just skimming through this, I see a couple methods that seem interesting. So I'm just going to keep that and move on to the next. The last one is just a big conditional. It looks like depending on if we were successful or not, we'll return something, and if we weren't, we'll return something else. Now, we don't really care about the return value here, so we can get rid of that too. What we're left with is pretty straightforward. So now let's really read and try to understand. So we run some callbacks, and then depending on the value of scheduled at, we'll branch. Since we're not scheduling anything here, we can ignore that too. And what we're left with is a single line of code that calls out to queueadapter.enqueue. So let's follow that. We can call queueadapter on our job, and we can grab the enqueue source code. And here we see something interesting. We're pushing a job into Sidekick, and as part of that, we call job.serialize. Let's poke into job.serialize next by getting a new job, getting the serialize method, and taking a look at what it does. And it's just one big hash literal. It's made up of attributes on the job and global values. Now, it would be really nice if we could somehow sneak our request ID in there. And because this is an instance method on the job, we can do that pretty easily inside of application job. Let's add serialize, let's call super, and then let's merge our value into that hash. Let's see if that worked by setting the request ID, getting a new job, calling serialize, and then grabbing the request ID. And it's set, so are we done? Did we add it? Let's give it a try by setting the request ID and queuing the job, and then checking in Sidekick. Still nil. So we're missing something here. Something active job is doing we haven't found yet. But we've kind of come to the end of our path. We've gone all the way till we're pushing the job into Sidekick. So let's just review what we've done so far. We've looked at report job.perform later. Then we called jobber instantiate, and then followed that down to enqueue. That led us to queueadapter.enqueue, which told us about job.serialize, which we were able to extend, and then Sidekick client.push. When we think about where to go next, we can kind of look at the full process that we understand so far. We call perform later. Active job calls in queue, serializes the job, pushes into Sidekick. Then in the Sidekick process, something happens, and then perform gets called on our job. So we want to know what's in that box. And when I'm stuck and not sure where to look next, I go look at the gem code. Now we can do this by closing our Rails console and then calling bundle open. If we give it a gem name, it'll open it up in our text editor. Now, if you run this and you see this message, it's easy to get around. Just make sure to set the editor environment variable to whatever command line tool opens your editor. This is for Sublime, this is for VS Code, Vim, and I believe most will have this. And once you do this, make sure to put that in your bash profile so it works in every terminal window. Once you do that, we can open up Active Job. But now we're faced with a whole gem full of code. Where do we start? Well, we know something's happening in Sidekick. So let's just guess and search for Sidekick in the code base. We get one piece of code that mentions Sidekick. It's the queue adapter. And again, it's a wall of text. So let's squint, find the natural sections, and again, I see three. The first is the enqueue method, and we've already seen this. This is the thing that pushes the job into Sidekick. So we can ignore that as well. The second is the enqueueAt method, and it looks really similar to enqueue. The only difference is this timestamp. Now again, we're not scheduling anything, so we can get rid of that too. And what we're left with is a Sidekick job with a one-line perform method. It takes job data, it adds something to it, and then it passes that along to base.execute. It'd be really nice if we could open a console right there. So let's do that with ByBug. ByBug is a built-in debugger that comes with any new Rails app. And once you add it, restart your Sidekick console, and enqueue the job, when that job runs, you'll see this, a by-bug prompt. Now this will behave really similar to a Rails console, and we can inspect the job data. When we do that, we can see it is the serialized hash that we added request ID to, and we can even pull that out. And so next, let's dive into base.execute. We look at this code. It does a couple things, runs callbacks, and it calls deserialize on the job data. We can dive into deserialize next, and we can see that it constantizes the job class and creates a new one, and it calls deserialize on that job, passing along the job data. Now we can get that class by just copying this code down to our console and grabbing the deserialize method. And once we get that, we can see this is where the important work happens. We take values from job data and some global values. We assign them back to attributes on the job. So again, it would be great if we could just assign request ID in here. So why don't we go back to application job and do it in the same manner as we did with serialize. So add a method, call super, so we keep all the existing behavior, and then set request ID. So are we done now? Let's go back to the console, set request ID, call perform later. When we go back to our sidekick console, it works. We have done it with only our terminal and text editor. We have added request ID for every single job. And to do that, we had to modify serialization and deserialization. So somebody gave us a question. And to figure out what to do next, we looked at a method that we had called many times and understood pretty well. And to find an answer, we had to skim about 100 lines of code and really understand about half of them. So we have come to the end of our spelunking journey. I hope you've all enjoyed your trip and you've been wonderful companions here. I hope that the techniques we've covered today have only just scratched the surface. There's so much more to these ideas, and I really encourage you to practice them on your own if you're interested in learning more. It's also worth digging into bybug, which is the debugger we just touched on briefly. It can do a lot more than we looked at today, stepping through your code, stepping into methods. And pry, which can replace your default Rails console and even act as a debugger. And it adds a lot of features to Ruby spelunking, like shortcuts for method introspection, syntax highlighting, command history, and it can even dig into C code if you really want to. Or actually, just found this out recently, you can ask an object where it's been monkey patched, which is really neat. So, other people's code can be confusing, can be frustrating, can be scary. And I'm sorry to say that it's not going anywhere. But here's the good news. There are things you can learn and practice that can help you more confidently explore any unfamiliar code that comes your way. And if you invest in your ability to understand code, a small improvement here can have a really big impact on how much code you can write. Remember, you don't have to know the answer. You just need to know where to find it. Thank you.